With the power of inspector plugins, you can completely change how the Godot inspector works and displays information. You can make custom displays, interactions, and all sorts of things to help you improve your workflow. And they are easier to create than you think. So let's see how we can make them. So here is our simple scene. We are going to give our player's entity class here a special custom inspector. But to do that, we first need to create an add-on. So let's go to the project settings, and on the plugin tab, click on the Create New Plugin. We'll name this Project Plugins, where all the custom inspectors and gizmos of the project will live. Then hit Create, and a new add-ons folder should be automatically created with the new plugin inside it. So let's open it now. Add-ons in Godot are very simple. They are just a GDScript node that runs while the editor is running. Let's start by removing this, since we are not going to use autoloads. Now, when you enable or disable your plugin, this script is instantiated and added to the Godot editor's internal tree system. So the enter tree function is called when the plugin is enabled, and the exit tree function is called when you disable it and it is removed from the tree. As simple as that. But to change the inspector with this add-on, we first need to create a new script. This one is of the type Editor Inspector Plugin. And we'll call this one Entity Inspector, which will be the custom inspector for our entities. This class is what connects us to the inspector, but first, we need to register it. So let's go back to the plugin script and drag a reference for the inspector plugin class. You can hold Ctrl to automatically create a preload here, which will use the UID for that file. But if you plan to use this for more than one project, you can instead hold Ctrl and Shift together before releasing it, and it will use the path instead, since UIDs are not compatible between projects. Then, we'll create a variable named Entity Inspector of the type of our script, and when we start the plugin, we will instantiate it with Entity Inspector equals entityInspector.new, and use the Add Inspector plugin to add a new custom inspector to Godot. Then when the add-on is turned off, we check if the Entity Inspector exists and unregister it with Remove Inspector plugin. Now we can go back to our inspector plugin and start to make changes. To use a custom inspector is actually very easy. First, we need to override the canHandle function. This is called whenever an object is selected and asks if the inspector plugin should handle it. So in most cases, you just want to check for the class. So if the object is of the type entity or custom class, we want to handle it here and we return true, else we've just returned false. You can, for example, use this for any 3D node or a more specific condition. But now, what can we really do with this? There are a couple of ways we can change the inspector, but they all begin with overriding one of these parse functions here. So to start, let's override the parseBegin function. This lets you add things right at the beginning of the inspector, and there are two types of things we can add. So first, let's create a button with var btn equals button.new and set its text to myButton. You can then use the add custom control that lets you add any control node to the inspector. And to see what this does, let's open the project settings and enable our project plugins add-on. Now, when we select our entity class player, we can see a brand new button right at the top. But the other more useful method we have is the parse property. This is executed for every single property of the current inspector, and it lets you decide where you want to add things. By returning true here means you don't want Godot to handle the original property. So by returning true and refreshing the inspector, now our entity class doesn't show anything anymore, which is not what we want, so let's change it to false. Inside here, we can check for the name of the variable we are looking for. So in this case, if name equals HP, let's create a new label and set the text to myHPLabel and add a custom control here. And there it is, we just added a text above the HP property. It's still not very useful yet, but it also means we can do anything we want here. So for example, let's drag this custom UI, instantiate it, and add it to the beginning of the inspector. And there it is, a fully interactive scene working right inside the inspector, and you can hook it up to do anything you want. But let's undo that and see the other way, a more proper way to work with custom inspectors. And that is with the addPropertyEditor function that hooks a property to a custom node. But before that, we are going to need to create a new class, which has the type EditorProperty. And we'll name this one Entity HP Property, since we are going to connect it to our player's HP. This special class is just like a control node at first, so let's recreate a button here and instantiate it on the init function and set the text to fill HP. But this time, we just need to use a simple addChild function to edit the scene, just like we normally would. Now, what's special with the EditorProperty class is that we can override the updateProperty function. This will get called every time the property it is connected to changes its values, and it also have references for the node and the property that are being edited. So let's do if getEditedObject, getEditedProperty, which is the HP in this case, is greater than 100, we disable the fill button, else we enable it. And let's also create an onButtonPressed callback to increase the health. We'll connect the signal with button.press.connect. And here, instead of changing the HP value directly, we use emidChanged with getEditedProperty, the HP, and the value we want. This makes sure the changed signal is propagated and the update property is called next. But to actually use this, we need to go back to the inspector script, drag in the property script, and create a preload. And right inside the HP property, we use addPropertyEditor with name and entity HP property.new. Now we got our fill HP button that disables itself after use, and will automatically update itself if the HP has changed. But you might have noticed something. We got the HP label on the left, which is usually not what we want. Another option we have is to set a third parameter to true, which puts the control button below the original property instead. And finally, the label, which lets you put a custom text label on the left side. But you can't remove it here, since leaving this empty we will use the original name instead. So we need to be a bit more creative. Back to the property script, we can set the label to be empty inside the ready function. But this leaves an empty space still, so we need just another thing. We can change the radial between the zones with the namesplit ratio. So setting this to 0 leaves us without the space to do whatever we want. And there we go, a button connected to a custom property. But just be careful when working with the object connected to the property. Since objects are not properly instantiated inside the editor, you will only be able to use serialized properties, variables that have the export or export as storage decorators. To be able to call the object's methods, they need to be using two scripts, which is a common mistake to make. But with those basics learned, let's see some more examples. Here, I have a better made health bar. It has a simple script to be able to click on the bar to change it, and another one to manage the bar's color, and some signals. Nothing too complicated. So I'll go to the HP property script, drag in this UI scene, create a new HP panel variable, and instantiate the UI health bar here. Then I'll add it as a child of the property, and you can use the addFocusable to give buttons inside the scene focus. Then I'll connect my changed HP signal from the health bar to emit a changed signal and change the HP property itself. And on the update property, I'll simply call the update colors, pass with the new HP to the health bar. And now, I have a health bar inside the inspector I can quickly change that is connected to the HP property. But changing the max HP property does not update the bar, so we need some way to fix that. Unfortunately, there is no simple way to get the changed signals to work for other properties in Godot, but there's another thing we can do. First, we need to get the inspector itself with editorInterface.getInspector and connect to its property edited signal. This gets called anytime a property is changed, so we can filter it for the one we want, max HP, and use that to update the bar's max range. Now we have a bar that affects the HP and will respond to changes in the inspector. And if you want to, we can return true inside the parse property to only show the new health bar. Now, the other example are 3D scenes. For this to work, we need to use a subviewport container, which has a viewport that holds the 3D scene. It is also very important that you check the viewport's own 3D world option, so the environment of the scene does not affect the editors. And finally, if you need to use a tool script to make a code run inside the inspector, but you don't want it running when editing the scene, you can check whether the code is inside the scene with get3.editedSceneRoot and then compare it with the script's owner. But that's it. A quick overview on how to make your own custom inspectors for your projects. As always, if you'd like to support me, you can get the project files by supporting me on Patreon, where I also post about some other small experiments I do every once in a while. I hope you like this video, and until next time.